Hello, I am Nilanko Haldar and now I am pursuing my MSc in Statistics from the Benares Hindu University and I joined an internship program in codsoft and this is my third task which is Iris Flower Classification Program and I complete my project in the Python with help of VS Code. At first, I import the important library that is import numpy, simpy, pandas, matplot, lib.pyplot, sblt, and cplot.cs. And then I import the data file and the kaggle. This is the ID dataset, and it contains uh, 150 rows and 5 columns and the column name is special sepal length, sepal width, petal width, and species. And data.info, I which is the sepal length is the float variable, special width is also float variable, and only species is the object. And data column is sepal length, sepal width, petal width, with species. And we check the null value. This code data dot is null for some parenthesis and this there is no null value and data dot decide we calculate some the statistical measure that is standard deviation minimum maximum and mean and count and the sepal length has minimum value is the 4.3 and maximum 7.9 and sepal with minimum value 2 and maximum 4.4 and total minimum is 1 and maximum is 6.9, total with minimum is 0.1 and total with maximum is 2.5. And then we draw a scatter plot of the sepal length with respect to the sepal width and we use the sns.scatterplot data equals to data x equal to sepal length and y equal to sepal width we species with respect to species and we have the three species there is iris setosa, iris versicolor and iris virginicea and this is the scatter plot and there iris setosas the minimum sepal length and there is the highest sepal width but iris versicolor and iris virginica is the same value with the sepal length and the sepal width. Okay, and we also the draw a scatter plot the petal length and petal width. This is uh, classified with respect to different species of the flower. This is petal length is and with petal width very low is iris setosa and then iris versicolor and then iris virginicea and this and data species that value underscore count uh, we count the frequency distribution of the three flower species. This is iris setosa 50 and versicolor 60 and iris 50 and this is the data my data. Okay, and we draw the paired plot with respect to species uh, and, and this is the sepal length corresponding sepal width this and this we draw the pair and we draw the histogram the different characteristics of the flower which is the histogram and this code figure A is PL to the subplot 2, and fixed size 10 by 10 and this is the list plot. This is the histogram of the sepal length, sepal width. This is the kind of the normal distribution. And this is the petal length and the petal width. we check this. Okay, I will check my. Okay, this is the petal width, and I also the block spot and this code. I using this code. And see, iris ethica is the normal distribution. Iris spectral versicolor species is a kind of positively skewed distribution because the Q1 difference then the this is the positively skewed distribution. This is also positively skewed distribution, and this corresponding the sepal length, sepal width, and petal length and petal width. Okay, this is the code, and this is the clock slot. Yes. And then we draw the heat map, the correlation, and at first we calculate the correlation between sepal length and sepal width and petal length and petal width. And we calculate the correlation with each other. And this is and I draw the heat map of the correlation and see the highest correlation between each petal length and petal width is 0.96 and petal length and petal and sepal length is the 0.87 and also petal with sepal length is 0.82 and petal length is 0.96. This is very high. Okay, okay, and sepal with sepal length is the negative correlation, slightly negative correlation. Okay, and this, and we see the values of the species. This is the this column unique, the iris species, and then we uh, draw the draw the cluster analysis, and this from sklearn.cluster import k-means, and at first we calculate the within cluster sum of square, and at first we define empty list, and by this code we calculate the within cluster sum of square, and this is by this is the within cluster sum of square, and this is very low, and last term 0.67, 0.25. This is the small change. Okay, and we draw the elbow curve, okay, by this code, and this elbow curve is not changing after 4. Okay, the number of value 4, and after the number of cluster is 4, and then the value is not change. So we draw 4 cluster by the elbow method. We check. Okay, and the number of cluster is 4. Okay, and we predict the value, petal length and petal width, predict the value. This this is a 1 cluster. This is a 0th cluster 3. Okay, 2, and we create a new column of the cluster 1. Okay, and this is the cluster 1, and we draw the petal length or petal width, petal, 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 and 4 clusters. Okay, this column, and we calculate the centroid. This is the centroid, and 0 and this 1.464. This centroid is this 1.644 x x 7, y is 0.214 is the centroid. also is the centroid value, center, and we convert the categorical column to the numerical column by this code. Okay, and we draw the conclusion and we create the conclusion matrix where the number of species is 3 and class is 4. This is the conclusion matrix. And again, we calculate the within cluster sum of square of the data is sepal length and sepal width. And we create this previous one as the previous one. This change is very low. And plot the elbow method similar way. Then after 5, this is not changed. So we take the number of clusters is 5 and we predict the values. Okay, and we create a new column, which is cluster 2. Yes, as we convert the category column to numerical column and this is the cluster 2. And this is the centroids, and we also create a conclusion matrix of the data set. Okay, complete my project. Thank you.